So now that we have created the basic framework for our sprite system, let's test it out. By the end of this video, here's what I'd like for us to have accomplished. Number one, I would like for us to have instantiated the sprite sheet. From there, let's instantiate a sprite. Let's pick on maybe an asteroid because we've set up all of the code to handle animation, and we know that with the asteroid it's going to rotate, so it would be really cool if by the end of the video we saw a rotating asteroid in the middle of the screen. So, where are we going to create the fields to hold an instance of a sprite sheet and an instance of a sprite, which will be our asteroid? Good question. In the past, with all previous games and engines that we have done in the XNA 101 series, we've always created fields and local variables right there in the game class itself. And that was fine for those smaller examples. But with Space Fighter, we're dealing with a relatively large project. Even though we're not following this all the way through to completion with a final game, it's just going to be an engine with a pretty well-developed game in it. It's still not going to be a good place for us to create all of the fields, that being in our game class. And what I'm talking about with fields, I'm talking about fields that describe the characteristics of things that are happening within the game. We've seen fields like this in the past. Things like screen width, screen height, player health, enemy speed, etc. Instead of having tons of fields, and trust me, we're going to have a lot of fields by the end of this project, all available in our game class, let's move them somewhere else so that we can keep our game class nice and clean. So in this video, before we instantiate a sprite sheet and a sprite itself, and that sprite, by the way, I just want to point out is going to be a temporary sprite, just to verify that the system is indeed working, because we're going to be using a node architecture, and the node architecture is not in place, so it's not like we can create a node that's going to be an asteroid, that's going to reference a particular sprite. That good stuff's coming later. So before we start creating these two instances, let's first create a config class. This config class will be an excellent place for us to store all of the fields that will be used to describe the many different elements that will be in Space Fighter. Things like the screen width and screen height. How about sprite sheets? Sprite sheets is something that we're going to need to load only one time at the very beginning when our game launches. And then as we are spawning new sprites in, those sprites can make reference over into the config class to sprite sheets that have been loaded in. So it's a really nice container basically for all of the things that we need to set up at the very beginning of Space Fighter's launch.
It makes a very good centralized place to get settings too, because in the past we would very often have different classes in any given example project that would reference things like game1.some setting. For example, game1.enemy health would be a possible reference. Here, with everything being centralized to config, it makes a little bit more sense as you're reading through it, as you will see values like config.enemy health or config.enemy speed. And so it's very clear that this is a configured value that is being used at any given point in code.
Precisely. So our objective by the end of this video, to see a spinning asteroid and to have a config class in place. But first, there's something that's managed to slip up under the radar. Namespaces. You guys have seen that we've been using folders to store our classes, and as we use folders, our namespaces reflect that. Namespace, dot, and then our subnamespace, engine, representing the folder that the class is being stored in. And generally, when we put together our projects, we eliminate the subnamespaces so that everything can work with and see everything.
Exactly. We're using this as almost more of a project organization mechanism than an assembly organization mechanism. So in the past, we have always stripped the subnamespace and simply allowed all of our classes to look like they are in the same, or rather reside in the same namespace.
Exactly. And so far, we haven't had any trouble whatsoever with the code we've put together, and each time we have built the solution. But let's think about that. All of the references between the classes have all been classes that exist within the engine folder, so everybody can see everybody. But we're about to create this config class. Configure the game. This is something that is game specific as opposed to being engine specific. So once we create the class over inside the game folder, then we can start running into some issues with one class being able to see another class that happens to reside in a different folder. So by eliminating these subnamespaces, we'll be in good shape.
So very briefly, before we even look at the config class, I'm going to go through and wipe out all the subnamespaces referencing engine. So beginning here in Sprite, we can then move on to events, and finally look at sprite sheet. And in each of them, we'll remove the engine subnamespace. And if we want to, we can get everything saved and built, and everything is working.
Okay.
So now we can address the config class. To do that, I'm going to go down to the game folder, and we'll add a new item to it. This new item is going to be a class called config. And inside of the config class, a few things need to be tweaked, beginning with the subnamespace. Here we have a subnamespace of game for being in the game folder. We'll erase that back off, and I'm also going to remove the using statement to system.txt. Now, let's talk about the game class, or excuse me, the config class for just a second. At the moment, of course, by default, it's just a normal class, which means it can be instantiated, and it can have a bunch of instance fields inside of it.
Wow, that would be kind of odd to have instances of config.
But in that case, that would be completely unnecessary to have multiple instances of configuration when we're looking at this as the repository for configuration information.
That's right.
So what we're going to do is we're going to declare the entire class as static, and along with that means every member we put in it will also have to be static. So this will be a static class. Now, inside of config, this is of course where we would want to jump in and start putting screen width, screen height, and initializing sprite sheets. But before I do that, there is one more method in addition to the information we're going to put in here, and that is a method. I'm going to jot it down, and we'll explain it lightly. We'll get back to it, though, a little bit later.
We won't even explain it lightly. All I've got to say, it's a very unique method in such that there will be no implementation. It's going to be empty.
And that will be the initialize method. Public static void initialize, no parameters, and no
That's
code
it.
in the body.
No implementation. Oh, but trust me, it initializes, and you shall see very soon how. So we'll come back to it.
Now what I do want to address, and this will make more sense more quickly, and that is we would like to now set up the configuration for a sprite sheet. More specifically, let's set up the asteroid sprite sheet. Now all of these fields are going to be public, since we want to be able to see them from elsewhere. They all have to be static. And this first one is going to be of type sprite sheet.
And it makes sense that they need to be static. I mean, outside the fact that we've got the governing rules that we're in a static class, but how many sprite sheets referencing, well, the same sprite sheet idea, in this particular case the asteroid, do we need? Just one. Every sprite that we create, all of those guys that are of a particular sprite sheet type can reference that one sprite sheet. So we don't need a bunch of these
Exactly.
guys.
And that's also how the information in sprite sheet has been organized. If you go back and look through all of the members, all of the fields of sprite sheet, generally those are the things that are common between all instances of asteroids. All the asteroids are going to animate at the same frame rate. They're all going to have the same texture. They're all going to share the same dimensions using tiles. So all these things are going to be the same for all the asteroids. And therefore we need only one sprite sheet. So getting back to this sprite sheet, this is of course the asteroid sprite sheet, so that's exactly what I'm going to call it. Asteroid sprite sheet. And we will go ahead and initialize it using a field initializer, so we'll immediately turn around and say new sprite sheet. And now we need to specify a series of parameters to satisfy the sprite sheet constructor, beginning with the asset name. Now, of course, if we were to go back and look through things like the load content method inside of Spritesheet, we know that that gets referenced by a content manager and turned into a texture 2D. So, and as far as we're concerned, where does that asset name need to come from? What does it need to link to? Well, we can gain that information by loading or looking into the contents of project, and there is the graphic that we'll be using for asteroid, and we can see that its asset name is in fact asteroid. Again, I'm just being overly careful in pointing this out because I know all of that would be simple if you were looking at this from the game 1's load content method, but just keeping in mind that things have kind of been moved around a little bit with this architecture. So the asset name asteroid is actually going to go over here as we instantiate a sprite sheet. So we can plug that in, the string asteroid. The next thing we need to get is the number of tiles in X followed by the number of tiles in Y to describe how many tiles are part of this sprite. And the easiest way to find that is to simply find that graphic and count off the number of tiles. So let's jump over to our working folder where we have our images stored, and we have our asteroid PNG graphic, and here we go. Looking at tiles in X going across the graphic, we have 1, 2, 3, 4, 5. So we'll have 5 in tiles X, and in tiles Y we should have 1, 2, 3, 4, 5, 6. So this is where we'll get our numbers in order to populate tiles X and tiles Y. If I bring code completion back up, we can set tiles X to a value of 5 and tiles Y to a value of 6. The frame rate I'm going to specify simply as 15 frames a second, simply because in testing I found that to look quite nice. And that wraps up our call to the sprite sheet. You will note that we omitted things like specifying a sprite sheet mode or specifying a frame count. We left out frame count because we know that we're using all of the tiles. There's no reason to specify fewer.
That's right.
And I left out sprite sheet mode because we know that it defaults to a sprite sheet mode of normal.
Normal, yep.
And that's exactly what I want for asteroids. I do want asteroids to have damage textures. So we can terminate this line, and that takes up the configuration for asteroid sprite sheet. Now we can turn our attention over to the game class and set up a test scenario in which we can spawn a sprite. So I'm going to collapse the content subproject and open up our game class. Now down here in the game, the first thing that I want to do is set up a field in which we can store an instance of sprite. So I'll make a sprite field that I'm going to call test sprite.
Yeah, this is all temporary stuff here.
Alright, this is just put in place because we have no other place for sprites to live. We do not yet have the node architecture in place. Now moving down from our fields, the first thing I want to address is the initialize method for the game, and I'm going to use this to call our config.initialize method.
This is not temporary. This remains.
And we'll get to exactly why here in just a minute after everything is working. Now moving down, the next method we have is the load content method. Inside of load content, we're going to call upon our static functionality found in sprite sheet. That functionality is load content. This is, of course, the method that's going to go through all sprites that currently exist, at the moment all one of them, the asteroid sprite sheet, and make sure that that asset name string is turned into an actual texture resource. In order to accomplish that, it's going to need access to a content manager. And because of the yet to be implemented damage texture functionality, it will also need access to a graphics device, both of which we have access to inside of our game. The content manager is just the game's content manager field. And there we have content manager. And the graphics device, hang on, let me look at.
Just over content.
Content. I typed in content manager, which is the type, not the thing. So this.content, and along the same lines, we're looking at the game graphics device field held inside of the game as well.
Cool.
Once again, this is basically the source of these two things. We're using a content manager in Sprite. We're passing through a graphics device.
Right.
We were just looking at those almost like imaginary ideas when we were inside of the sprite sheet, but here in game we can see that this is where they really come from.
And this is also not a temporary line either, because we're calling upon sprite sheet to load content, and once again that's going to load all content, meaning all of our textures into all of our sprite sheets.
Exactly. So once we get into a scenario where we have all of the game's sprite sheets defined in config, this is the point at which all of those textual asset names are loaded in, so all of our sprite sheet texture data.
Exactly.
All right. Moving on from load content, we're actually going to introduce a, new method as far as we're concerned as it is used in the game class. What we need to accomplish here is the actual creation of the sprite itself. But the way that I'm looking at this is almost like the scene setup phase of the game, or you can almost look at it as the level loading. Mm-hmm. Basically, the point at which in our game's execution we need to start adding objects to the game. That's kind of the way I'm viewing this. And I want to have this set up in a method separated from load content. I know in games past sometimes we would have a relatively simple topic, and so we would simply send off the final data objects that we would need from load content. Here, though, I want to separate the idea from loading content and scene initialization. And I'm going to do that by utilizing the built-in begin run method that is part of a game class. It's not a method that we see by default using the game template, but it is one we do have access to from the game. As a matter of fact, let me show that here. If I were to jump down anywhere in the game class, I'm going to jump down below the unload content method. And we type in override and hit space so we can see a list of all the protected methods in which we may override. we can see that one of them is begin run. If we look over at the tooltip, we can see that it's called after initialization, but before the first update in the game loop. So before things are put into a continuous update state, we get a chance to run this method. And this makes a great place to do things like scene setup, because we know that it's going to happen after load content, so we have access to whatever we need to in order to place things on the screen, but before update is run. So we'll get everything set to an initial state from within begin run. So we'll go ahead and drop begin run in, let it finish off the method body. And inside of begin run is where I'm going to instantiate a new sprite. We'll store that new sprite into test sprite. So test sprite will be equal to new sprite. And sprite needs access to a sprite sheet. And here's the point at which the config class starts to become truly useful. This is, of course, not the only time in Spacefighter that we're going to need to make sprites. We will actually need to make them quite often. If we need to make a player, or an enemy, or an explosion, or any other of the objects that exist that have sprites, we always need to be making new sprite instances. And having all the settings that represent sprite sheets all wrapped up and encapsulated into sprite sheet instances is very convenient. Now, instead of having to describe, well, okay, the asteroid has X number of cells, it has tiles X, it has tiles Y, it has a frame rate, we've already taken care of that.
Yep.
We can call upon config and tell it, and grab some spelling, config, and one of the things we have here is asteroid sprite sheet. Pass that along to sprite, and we're ready to go. So very easy to read, and we don't have to worry about many different places in code where we have different numbers to describe sprites. We simply know that, use the asteroid sprite sheet in order to make this sprite. So moving on from here, just two things left, and we can actually test out our sprite. One is draw, and the other is update. Let's actually jump down to draw because this is most simplistic. Inside of draw, we need to do our obligatory calls to begin and end. Sprite batch, and a little bit of fun with spelling, and then we get sprite batch.end. Between these two lines, we can now draw our sprite. Tell our test sprite to draw using the given sprite batch inside of the game. We also need a position to draw the sprite at. I'm going to draw it in the center of the screen.
Yeah, let's go ahead and center it up.
So I'll make a new vector 2 with values 400 by 300 to give the center of our 800 by 600 screen.
You can actually go ahead and run right here. We should see an asteroid. It won't be
moving.
It won't be moving, but it'll be there.
So if we were to run,
look at that.
We see just that. We have an asteroid graphic centered in the middle of the screen. Everything is drawing, no errors, but no movement.
But this tells me that we've got our config class working properly, that we have indeed instantiated a sprite sheet, that we've properly set the texture up in the sprite sheet, and that we've created a sprite that's now referencing the sprite sheet and is now being drawn to the screen.
So a lot of things are in place and working, even though this looks like a simple result. But because we do have a bit of an architecture working as a backend here, that means to enable animation, all we need to do is make sure that sprites receive update information with the current time. So we can tell our test sprite that it should update and give it the current time in game time.
And it comes to life.
And now we have full sprite animation.
Beautiful.
So that accomplishes the goal that you had set out for. We've got a test sprite animated and on screen. But before we jump past, I do want to point out what is going on with this config.initialize method, the one that inside of config is still empty. Why on earth do we need to have this? Well, let's take a look at an interesting scenario. And the reason there's an interesting problem that can occur, and the problem stems from the fact that I am using field initializers on static fields inside of a static class. Because it's too easy to think that config will simply be run before everything else by magic. We haven't actually told any of this stuff to execute, and because we're using field initializers, things are even a little bit more magical, because now it's, well, something makes it exist. The big question to keep in mind, though, is when. When do these things start existing? To have a little bit of fun with that, what would happen if we took our current situation and simply didn't call initialize? You wouldn't think that that would change the way the game would run, because it doesn't do anything. But what happens if we try to run?
Break.
Look at this.
Breakage.
We've tried to run...
Broken.
We've tried to draw the texture, and we've got a null argument exception, and texture is null. why on earth would that be null? We have this nice field initializer here that's supposed to run a sprite sheet. That's supposed to make everything exist. To make it a little bit more clear what's going on, let me actually stop and I'll set a debug point so we can see another interesting thing that is happening. If we go over to sprite sheet and we go to the load content method, let's take a look at what's happening here. Let's look closer into the whole texture being null issue. I'll set a breakpoint on the for each loop here and rerun. And if we look at sprite sheets, there's no sprites in them. What that tells me is that this line back here in config has not yet run. Otherwise, we're saying new sprite sheet. Sprite sheets, if we go back to the class, get added to their appropriate sprite sheets list.
And we talked about this a long time ago when we were discussing static classes. Something has to be touched in the static class to cause all of the initialization to occur.
And that is the key. This whole idea of, well, the fields automatically just exist is only true in a case where you have, for some reason or other, used that class. What that means is when we were making our call to config.initialize, okay, we're hitting that class. We need to initialize things. Oh, wait, we have field initializers.
Exactly.
We need to get this class set up and ready for use because game 1 is calling upon it here. If we took that out for some reason, the whole reason I'm pointing this out is that means with taking out an empty method, we suddenly change the functionality of the game. And you have to keep in mind the way the field initializers are acting in relation to the static class, in that the static class is not getting set up. These field initializers are not getting run until the class is needed. Since we hadn't called it before load content, it was too late by the time we got to begin run, because here we hit config, begin run happens after load content, which is too late. We've already skipped the sprite sheet.
Yep.
So just wanting to point that out, that this call to initialize here is really using initialize as a form of anchor to make absolutely sure that we can, well, poke the config class and tell it to get set up, including field initializers.
Did you take your breakpoint back out?
I don't think I have. Well, maybe I have.
Maybe you did. Excellent.
But
having that in there is just kind of saves the day, because once again, it looks as if we're going to use something in this static class, and because of that, everything in it, all of our fields, get initialized.
And another way that this could have been formatted would have been to have taken our fields and declared them and initialized them on different lines. We could even have gone so far as to have put this code into the initialize method, where the initialize method would really actually handle the initialization of the fields. But the reason I opted not to do that was that would require 2 lines per field setup, whereas using field initializers requires only 1. And
It's just cleaner looking.
I like the fewer lines being used in that case and not having to manage 2 things at one time. But again, the trade-off here is the fact that we have a somewhat obscure use of this method, where we're simply using it as a handle to get back to the static class. Another thing I'll point out is you're not always relying on this by itself. If you were to, for some reason, rely on config or grab something from config in any place other than initialize that is before load content, the program will seem to run just fine.
Mm-hmm.
We're just leaving this here as a solid anchor that no matter what uses or does not use config, we always get the static initialization to occur.
That's right.
But now that we've got that covered and the example working, there is a couple more fields that I'd like to get put into place simply because I want to use this as really the start of our configuration. I want to address 2 fields that have been fairly common throughout all of our games, and that is a screen width and screen height setting. Convenient setting that not only sets the resolution, but gives a point of reference later, so we can query the screen resolution. So the fields I'm talking about are screen width and screen height, and let's go ahead and drop them into config. We're going to make these public static integer fields, first called screen width, setting that to 800, and a public static integer screen height, which will be set to 600. Now, just to make sure that all the appropriate linkage is put into place, we're going to turn right around, go back to our game class, and use these inside of the constructor. So we take graphics.preferred back buffer width, and we'll set that to config.screenWidth. And then we could copy that line, duplicate it, and change preferred back buffer height, or excuse me, width to height, and screen width to screen height. So now we have that in use, so if we ever change the configuration, the game resolution will also be changed to reflect it. And also I'll point out here that this is a use of config that comes before config.initialize. So we get into one of those fuzzy areas I was talking about, where now magically we could comment that out. As a matter of fact, I'll run just to show everything working. Matter of fact, we could comment that out now, and the game continues to run. But the whole point of bringing this up is to show that it is very important that config be looked at before load content occurs.
That's right.
And this makes a good anchor point for that. But really, I think that's all that we needed to cover in this video.
Yeah, you've accomplished exactly what I asked for at the very beginning. I just wanted to see a spinning asteroid in the middle of the screen.
But the config class will come in very handy as Spacefighter grows.
Without a doubt. All right, well, with that, that is going to wrap up this video. Thanks a lot.